Hello and welcome back to another episode of Mitsubishi Mastered. I'm Tim Hyder and I'm going to be your host today. We're going to be looking at the MX controller again, and this time we're going to be looking at encrypted communications. Adhering to IEC 62443-4-2, one of the first PACs on the market that is able to do this, and I just want to give you kind of a preview of what that might look like, looking at how our programming software, Works3, communicates to the MX controller. Let's begin. So we have a demo here. As I said, we have the MX controller. In this case, we have the MXR300. We have two Ethernet ports. The top, and they're both CC-Link IETSN ports. They're on the network 192.168.4.253. And the top port we have connected to an MRJ5 servo amplifier, and the next port we actually are tunneling Ethernet through the TSN, talking to an HMI. On the other side here, we are actually talking to Works3, our programming software for the PAC. And what we're going to do is actually Wireshark or packet capture the data and look at it through Wireshark. And if you're not familiar with that, don't worry, it's not something you really need to focus on. Just know that that software allows us to see all of the information that's being sent cyclically through the network. So let's begin. I have Works3 open. I already have a project started. I can go to connection destination and click on Ethernet and standard Ethernet. I'll double click this, TCP, OK, PLC module, 3.39. I could hit find if I didn't know what the PLC module was. It will go out and it'll find it, 3.39. Sure enough, there it is. And then timeout 3 seconds, and I don't need anything else below here. If I do a connection test, successfully connected, perfect. This is normal. This is how we would normally connect to all of our previous model PLCs. But what I want to show you is that all of this data is visible on the network. And this isn't just programming software to the PLC or PAC. This is the HMI communications. This is PLC to PLC. This is PLC to, over a socket, Ethernet connection to a robot or to a Cognex camera or to whatever it might be. We now offer the ability to encrypt that traffic. And I'm just in this video, I'm only going to be showing our Works3 software, but it could be used for a variety of different things. And the thing to be thinking about is if a network, or if a nefarious actor wanted to see what the traffic was and duplicate and mimic it or change it, he could. He could grab that information. He could show fake data on the HMI. Maybe he's saying that the VFD is only running at 60 hertz, but then in the PLC, he can go in and can actually say, no, run it at 200 hertz. So the operator thinks, hey, it's running at 60 hertz. In actuality, it's 200 hertz. The power plant crashes, etc. So bad things can happen. So if this is a concern for you, let's do this. I'm gonna open up Wireshark, and I'm just gonna hit go, and we're gonna just look at this data. Now, actually, let me do capture options. Make sure I'm on the right one. Ethernet 4. Yep. Now I can come back to my program, my Works3, I can hit start monitoring all, and now that I'm monitoring traffic, I can go back to Wireshark, and I've got a bunch of stuff going back, forth, back, forth, back, forth. Right now I'm filtering by my PC and the PAC. So the MX controller PAC is 3.39, and my PC is 3.166. So I'm just saying, show me all the data between these two things. I could hit stop here. I could click on PLC information 3.39 to the PLC to the PC. Sorry, it's going to be a confusing video, I know. But then I get this information here, this truncated data, and I can see a bunch of stuff in here. And it might look confusing to you. This might not look like anything, but this is the raw data. This is easily available. And I want to show you an example of what I mean by that. If I come in here to the watch window and I type in one of our addresses, I'll say D1000. I'm not using that in my code. It's just a 16-bit or 32-bit, however I want to use it. A register sitting there, I could put something in there. So I could come in here, current value, and I could say a 1. Or I could say, I don't know, 5,000 or 500, sorry. If I change this though to a double word and I say hex to decimal, I could put a hex value in here. I'm going to use kind of a classic hex value. If you are familiar with, this is kind of old, but if you're familiar with PCs and memory, memory management, memory allocation, and programming, this could be an error code that used to be thrown, that you would know immediately that there was issues with memory allocation, and that don't worry too much. But in hex, this is a legitimate, a value, so I can say dead beef. Enter. So now dead beef, I wrote that to that D1000. So now the question is, can I see that in Wireshark? And sure enough, I can. So when I come here, I'm going to start capturing again. So continue. So now all the packets are coming, and we can see hundreds of packets a second are coming through here. I can do a search. I can come here to find packet, hex value, and I'm going to just start with DE. Actually, if I look at just dead, so DE, AD, this is not going to show up. And you have to know a little bit about how memory works. We use little endian, not big endian in our PLCs. Don't worry about that too much, but these pieces of information are swapped. So I need to put the AD first and then the DE. And when I do that, I immediately have something I can look at. So I'm going to stop this packet capture, and I'm going to see right there it is. And it took me to a packet 3.39. This is the PAC talking to the PLC of length 183. And if I look closely, here is DEAD. So that's dead, BEEF, beef. There it is. Plain as day. If I would capture this, and if I was a hacker, I could program some stuff, do a little bunch of tweaks, and I could send a different value to that D register. That's what we mean by it's unencrypted. It's just visible. I didn't do anything special. This is an open source tool to just see what the packets look like. Now let's encrypt that. And I want to work you through, and it's going to take a few seconds, a few steps, but it's really super easy. But just bear with me. I want to show you what that looks like. So first thing we're going to do, let's create a certificate. This is in the X509 form. We'll create a certificate, put it into the PAC. So we come here to project, security, certificate management, MX controller. As a server, our PC, our GX Works3 is going to be a client. We're going to talk. So from a server perspective, if I click update, there's nothing in there. I want to create one. So, sorry, before I do this though, you have to verify that your PC and your PLC time is correct. So let's close this out. Let's go to tools, online, set clock. And here we can get the time from the PLC or from the PC. And when I get time from PLC, it matches what my PC's at. If it didn't, I could say get time from the PC, and then I could execute that down, and now they're both identical. If they're off, your certificates will be off, it'll be a mismatch, and you won't have success. So that's step one. We're good there. Let's come back to project, security, certificate management, create. Organization name Mitsubishi. This is you. You put all this in. So organization, you don't just say ME for Mitsubishi. Locality name ME Mitsubishi Electric. State, I'm in Ohio. Country, US. The state and the country I think both need to be just 2-character cap. Expiration date, so 1 year. You could actually make this up to 20, but per the IEC standard, it's recommended 1 year to adhere to that. So we're going to leave it at 1 year. And after 1 year's passed, I'll need to make a new certificate to make this happen. Hit execute, hit yes. This is going to take a second. It's going to create the certificate, and it's going to push it down to the PLC. Oh, sorry. Let me come here over USB just to make sure that I don't lose connection, because I was doing packet capturing. And let me stop the packet. Oh, it already is stopped. I don't know, something glitched. We'll do it again. Security, certificate management. Did it take? Oh, it took. All right, it took, and then it just kicked us out. So it's there. MXR 300. It's got the date buried in there. Now what I need to do there is read that, because I want to put that onto my PC. So hit read and find a location for that. I've already got a certificate here. I'm going to delete that one. I only want the new one. Actually, I'm going to cancel this and do it again so that the name is correct. Find the location, blank folder, hit select, hit execute, and now that saved that certificate to my PC. If I go, yeah, save the certificate. Now I have to actually tell Works3 that I have the certificate. So I click on personal computer. Now it's going to act as a client. If I hit update, there's nothing there. I don't have one yet. So I need to register it, and I'm going to point it at that same location that I just saved, the same folder that I just saved that certificate. It's a .cer. Hit select, hit execute, and now it registered it to my PC. So again, if I go back to the MX controller update, there's it, and it will match exactly to when I go to PC and hit update, and there it is. And I've got a backup of it stored in that folder on my PC. Perfect. Now what do I have to do? Now I have to actually tell the MX controller that I want to use TLS. So I come into the Ethernet port 3, go into basic settings, external device, and I currently have one MailSoft connection that I've created. I want to create a secure one. So I come here to MailSoft and bring that in. Now in the drop down here, I want to say TLS, and I have to give it a port number. I'm going to use 6000 in this example. So 6000, that's it. That's all I have to do. I could come over here if I want and enable the keep alive. We can do that. So well, actually, I'm just going to leave that disabled. Keep alive, just if the connection gets dropped, it's going to ask, are you there? Are you there? Are you there? And then it will close itself off. And it's recommended to use that. I don't need it in this example because I'm doing basic, so I'm just going to ignore it. But just know that you would probably want to enable the keep alive. So I'm going to hit close, hit apply, check, no errors found. Actually, while I'm here, I'm going to go ahead and make one that's based on UDP. So I'm going to copy paste this, and we'll do a DTLS. So that's UDP TLS. TLS is based on TCP, so there's the handshaking type protocol. DTLS is built on UDP, where you don't have the handshake. It's not as preferred, but we can do it. So I'm going to put that one on 6001, and again, it has its own. It doesn't use keep alive because that's a TCP, but it does have its own UDP existence confirmation where it'll ask, "Are you there? Are you there?" And it'll close out. So close reflecting. Apply this down here. Come up here, hit right to PLC, execute that, and that is successfully written. Yes, okay, now we made network changes, so we will have to cycle the power to the PLC. It's offline, I know you can't see it. Power will come up here in a minute. I need to create a new connection destination, so we say create new destination, Ethernet, TLS. We'll make that the default, so we'll say yes, okay. Open, Ethernet board, yes. I know it's this guy, 3.166, yeah, network station. I'm gonna give the station number something far out. This is the station number of my PC. In the Mitsubishi world, we use IP address and network station number, and there's a long history that I don't want to go into too much here, but just know we do have to be concerned with this a little bit. There could have been already one device in my network. There's actually not, but there could be. So I always pick something kind of far out that I know, hey, there's not a station 64. I'm going to use that. The dropdown might not show TLS immediately. That's okay. Just leave it as TCP for now. We'll click OK. Come to the PLC and hit find. It's going to go out and find it, and it's say, oh, you're an MXR. Okay, cool. Now I know you're MXR. Let's go back here, and now we should have TLS. Great, there it is. TLS. Okay. Oh, I forgot one step. Go to the PLC. We'll never get connection if we don't fix the port number, and in this case, I put in manually 6000. So 6000, and then we click here. And we say 3-second timeout. Again, we don't need anything else below there. Let's do a connection test. Perfect, we're successfully connected. Okay, so now what I've done is I had an Ethernet connection. I've got now a TLS Ethernet connection, and I'm gonna go online. So it's monitoring everything. My value was deleted here with D1000. I'm gonna go dead beef again, enter, so that value's in there. But now that I have TLS enabled, when I come to Wireshark and I restart Wireshark, I've got a lot of information coming back and forth, back and forth. We can see the packet numbers here on the side, 100, 130, 150, etc. Now what I'm looking for, right, is that view, edit, find packet, hex value, ADDE, enter. Down here, no packet contain those bytes. It's gone. Everything's jumbled. In fact, if I look over here, it looks like just a bunch of crazy information. Here, let me stop it, and I'll find one from the PLC to the PC. This is all encrypted. I don't have the certificate key. I'm using Wireshark. I don't know how to read this. This is the beauty of encryption. So this will secure your data, make sure that if somebody is trying to hack, they don't know how to make sense of this, make heads or tails of it in general, and they're not going to be able to just change that VFD and change the HMI and have a runaway situation at a power plant or a wastewater facility, etc. We can do the same thing for DTLS. I'll do one more, create new destination. So Ethernet DTLS, which again, this is based on UDP. Yes. Connections changed, so we lost our connection. Fine, it's fine. Come here, Ethernet. Yes, Ethernet. Well, yeah, okay, so it's going to ask us here to do all this again. So we'll come here, make sure it knows it's an MXR, because the new MX series are the ones that support, they're the ones that actually can support this encryption. Come back here, now it should be available, DTLS, okay, yep, and then a 3-second timeout is fine. Connection test, oh, I forgot the port number, didn't I? So come here and we called that, I think, 6001, hit okay, connection test, yeah, perfect. Now I'll say okay, and online monitor. So now we're online monitoring, and stop, start. Yeah, so this should be, yep, we're good. We'll put in the dead beef again and come to Wireshark and start that up again. It'll look a little bit different. Instead of TLS, now it says DTLS, but same exact thing. If we do a search for the ADDE, so that's the word dead, you know, just in the reverse order because it's little endian. Enter. We'll look for beef. This is 100% accidental. These just happen to be in this order. If we would search for the entire string, sorry, I didn't think about this happening. EF. BE, yep, that one's there too. Yeah, so the data is still encrypted. We can't find the whole word, right? So even if we had dead, but we do AD, and we have that, there's no word beef around it. This is just truly randomized, and it just randomly had those two hex values in there. But we can see that it is all encrypted, and we can't make heads or tails of it. So apologize for my bad example, but hopefully you get the picture. We can do encryption. We can do that to the Works3 PLC programming tool. We can do it to another PLC. We can do it to third-party devices. If you have any questions, please reach out and we'll help you get this up and running. Thanks a lot and have a great day. And that concludes the video. Thanks again for watching another episode of Mitsubishi Electric Automation Mastered, where we show how quick and easy it is to become a master of Mitsubishi Electric industrial controls. Thanks and have a great day.